In this video I'm going to talk about buffers, and so the purpose of a buffer is to resist change in the pH of a solution. Okay, so for example our blood has a buffer system, and that keeps the pH of our blood very close to pH 7.4. So the way that buffers works, the buffers are composed of a weak acid and the salt from its conjugate base. And so the example that we've got in these slides here, there's acetic acid. So this is the formula here for acetic acid. And you could have the salt of its conjugate base. So for example, sodium acetate. So the sodium ion is just going to be a spectator ion. It's not going to do anything. So it's going to dissociate, so you get the acetate ion here. So in a buffer system you would have, for example, acetic acid and the acetate ion, both in appreciable amounts. Okay. So the way that buffers work is they resist changes in pH upon the addition of either acid or base. And so we'll look at both of those examples here. Okay, so if we add in some base, so this hydroxide here is being added in, that will react with the weak acid, and then that will produce the conjugate base as well as water. So it's going to shift the equilibrium towards the right. Okay, so then the products, we've got water is a neutral solution, and we've got this acetate ion here, which is not going to affect the pH very much. So if the buffer system wasn't present, this hydroxide ion would increase the pH, but because of the buffer system there, it's reacting with that weak acid to produce the acetate ion, so not going to affect the pH very much, and water, which is not going to affect the pH. Okay, so then upon the addition of acid, so if we have a buffer system and add in some acid to it, then the acid is going to react with the conjugate base there. It's going to shift towards the right, will form acetic acid in this example here, and water. Okay, so again, these products here are not going to affect the pH very much. Okay, so that's how buffers work. They resist changes in pH upon the addition of either acid or base. So we'll go through an example of how to calculate the pH of a buffer system. So I would suggest whenever you get a question that has buffer in it, you would use this formula here, this Henderson-Hasselbalch equation. So we've got the pH equals the pKa plus the log of the base over the acid. So in our question here, we're asked what the pH is. So we're trying to find the pH. We've got 1 molar CH3COOH and 0.5 molar CH3COO minus. Okay, so one of those is the acid, one of those is the base. The one with the extra H plus is going to be the acid. So in this one here, the extra hydrogen here, so this one is the acid. Okay. So we know the concentration of the acid, we know the concentration of the base, and we're given the Ka for acetic acid, and from the Ka we can find the pKa. Okay, so the pKa, the P means negative log, so the pKa is the negative log of the Ka. So negative log of the Ka value gives us a pKa there for acetic acid. So we go back to our formula here, so we know the pKa, we know the concentration of the base, which is 0.5 molar, we know the concentration of the acid, which is the 1 molar, and so log the base over the acid is the log of 0.5 over 1, which is the same as the log of 0.5. So you can do that on the calculator. You should get a value of negative 0.3. Okay, so now we know the pKa and we know the log of the base over acid. Okay, so then the pH is 4.74 plus that negative 0.3. So in this instance here, the solution has a pH of 4.44. Okay.